This 2-hour block of Revisewise programs is about maths. It covers problem solving, numbers and sequences, interpreting data, data handling, measures, shapes, space and mental maths. The starting time of each program is shown in the menu, so they can be found by using the clock in the top right-hand corner of the screen. First, problem solving.
Hello, I'm here to help you and our puzzling pupil make the most of what you know when you come to do your key Stage 2 maths tests in May. In each of these programs and in our books, audio tapes and on the internet, we're looking at the maths you might find tricky. Now this time it's problem solving. What do we mean by problem solving? Often the maths questions we get asked are just numbers on the page, like this. £2.20 multiplied by 6 equals... Go on, you try it.
Well, £2 times 6 is £12, and 20 pence times 6 is £1.20, so it's £13.20 altogether.
Yes. Now that wasn't too difficult, but sometimes the questions on the test paper wrap up the maths in a real-life problem which you have to solve. Try this question on the test paper.
Some children go camping. It costs £2.20 for each child to camp each night. They go for 6 nights. How much will each child have to pay for the 6 nights?
Have a go at it then.
Well, if one night costs £2.20 and they go for 6 nights, then the total cost will be £2.20 times 6. We've just done that, so it's £13.20.
That's right, you've solved the problem. There are 4 steps to solving a real-life maths problem. First, read the problem. Then, work out what maths you need to use to solve the problem, such as adding, subtracting, multiplying or dividing. Next, work out the answer to the maths. And finally, go back to the question and answer the problem itself. Let's use these 4 steps to solve a problem in a real test question. First, read the problem.
Here's a good one. There are 12 pencils in a box. A school buys 24 boxes. How many pencils does the school buy?
OK, for step 1, you've read the problem. Now on to step 2, to work out what maths to use. The trick here is to look at the story the problem is telling you and to work out whether things are being added together, taken away from each other, multiplied together, or is one amount divided by another. Imagine in your head what's going on. On the test paper, they help you with pictures of what the question is about. Here is a drawing of one box of 12 pencils. And here's a drawing of a stack of 24 boxes of pencils, with 12 pencils in each box. So always look at any pictures in the question to help you work out what maths to use. Over to you.
One box has 12 pencils, and there are 24 boxes, so it's 12 times 24 pencils altogether.
Right, now you've worked out what maths to use, write it down in the space where it says, show your working.
One box, 12 pencils, 24 boxes, 12 times 24 pencils altogether.
So we've worked out what maths to use. It's multiplication, and the sum is total number of pencils equals 24 times 12. On to step 3 to work out the answer to the maths.
OK, I want 24 times 12. I know that 24 times 10 is 240, and 24 times 2 is 48. So 24 times 12 is those two added together. That's 288.
That's right. Now that just leaves the final step to answer the problem. With this question, that is the answer to the problem. 288 pencils. So write it in the box for 2 marks. As well as writing your answer in the small box, it's really important to write all your workings in the large box. Then, even if you get the final answer wrong, your workings might show that you were on the right track, and you might get 1 mark. That question needed 1 bit of maths to get the answer. We just multiplied the number of pencils in one box by the total number of boxes. Some problems in the test paper may need 2 bits of maths to solve them. Try this one.
Okay, step 1, read the problem.
You got the idea.
A shop sells sheets of sticky labels. On each sheet there are 36 rows and 18 columns of labels. How many labels are there on 45 sheets?
Okay, on to step 2.
I know, work out what maths to use.
Go on then. And does the picture in the question help you?
Well, there's a picture of the sheet of labels showing that there are 18 labels one way and 36 the other. So each sheet has 18 times 36 labels on it?
Yes, so start jotting things down in the workings box.
Okay, one sheet has 18 multiplied by 36 labels on it.
Now that's 1 bit of maths, but I think this question needs more.
Oh, I see. They want to know how many labels there are on 45 sheets.
Yeah, imagine it in your head.
Well, if one sheet has 18 times 36 labels, then 45 sheets has 45 times that.
Yes, and show your workings out.
Then 45 sheets has 18 times 36 times 45 labels.
That's it. You've done step 2 and you've worked out what maths to use. It was 2 stages of multiplication. The total number of labels equals 45 times 18 times 36. Now, on to step 3.
To work out the answer to the math?
Exactly.
That looks a bit tricky to do in my head, so I could write it out.
Well, you could, but this question is on paper B, so it might be quicker to use a calculator. But don't forget to make an estimate first.
Well, if I make it 40 times 20 times 40, that's 4 2s are 8 times 4 is 32 with 3 zeros. That's 32,000. Now for the calculation. 45 times 18 times 36 equals 29,160. Well, that's not too far off my estimate.
So write it in the box for 2 marks. A lot of questions in the test are based on shopping and buying things. Now, shopping is something most of us are familiar with, but it can still be a bit tricky to work out the maths, particularly when there's money involved.
When you buy something and pay the right money, there's no maths to do. When you buy something and give a near amount, you use subtraction to get the right change. And when you buy 2 things, you add the 2 prices together and then use subtraction to get the right change.
Here's a shopping problem you can do in your head. Daffodils are 99p for a bunch. John buys 3 bunches of daffodils. How much does he pay altogether? Let's see how the maths team got on with this when they did their test.
I changed 99p into a pound, so it was £3, and then I remembered to take away 3p, which was £2.97.
So that's a money problem you could do in your head. This one's a bit more complicated.
Parveen buys 3 small bags of peanuts. She gives the shopkeeper £2 and gets 80 pence change. What is the cost in pence of 1 bag of peanuts? Well, that's all about shopping, but usually you know the price before you start.
Well, remember the second part of problem solving. Work out the maths in the story. The trick here is to think about what happens when you buy something and get some change, and then work backwards.
Well, if she paid £2 and got 80 pence change, then the peanuts must have cost £2, take away 80 pence. That's £1.20, so that's the answer.
But is it? Check what the question's asking.
Oh, it wants the price of 1 bag of peanuts. So I have to divide the £1.20 by 3. That's 40 pence.
Yes. And there were 2 bits of maths in that question, so it was really important to check exactly what the question was asking. Now here's a question that's full of tricks. Step 1, read the problem.
Right. Nicola has £50. She buys 3 flower pots and a spade. How much money does she have left?
Step 2, work out what maths to use.
Well, I suppose I add together the cost of all the things she's buying and then take it away from 50?
That's right. So go on to step 3 and work out the answer to the maths.
But how do I know how much all the things cost?
Look at the picture in the question.
Oh, yes. The prices of all the things are labelled. A flower pot is £12.75 and a spade is £9.65.
So in this case, the picture in the question doesn't just help you imagine what's going on, it has part of the maths hidden in it.
Now, this is in paper B, so I can use my calculator.
OK.
That's 3 flower pots times £12.75 each, plus a spade at £9.65 equals 47.9.
First trick to watch out for.
Oh yes, it's money. So 47.9 means £47.90. So the total cost of everything is £47.90.
Second trick to watch out for.
Oh yes, the question's asking how much money she has left from £50. That's £2.10.
So write it in the box for 2 marks. Now, what about the space for showing you're working? When you're using the calculator, you could think there isn't any working you can show. Well, in case you slipped up with your calculator and got the wrong answer, it's worth just jotting down the stages in your calculation so the marker can see you're on the right track, and you might get a mark. That's the end of our program on problem solving. So let's check what we've done. We looked at the 4 steps you need to go through to solve a problem. Read the problem, work out what maths to use, work out the answer to the maths, check back to the question to answer the problem. We looked at problems that need more than one calculation to solve, and problems involving money. If you want to, you can go over all this by winding the tape back and looking at bits of the program again. And there are also books, an audio tape, and our interactive Revisewise website to help you prepare for your tests. So, we'll let you get on with your test, and you get on with your television revision.
The next program is about numbers and sequences.
Hello, I'm here to help you and our puzzling pupil make the most of what you know when you come to do your Key Stage 2 maths tests in May. In each of these programs, and in our books, audio tapes, and on the internet, we're looking at the maths you might find tricky. This time, it's about numbers and number sequences. In the test paper, there are often questions like this.
Here is a number sequence. Write the missing number. Then there's a 1, a 3, a 6, and a 10, and a box to write the next number in the sequence.
To help answer this problem, you need to work out some kind of rule about what's being done to each number in the sequence to turn it into the next one. Now, once you've cracked the code and worked out the rule, you can apply it to the last number of the sequence, and that will give you the missing number at the end. Let's try an easier one first. How about this number sequence? What could you do to 1 to get 2, the next number in the sequence? Add 1. Yes, though you could also multiply by 2. So we can't be sure what the rule is yet. Look at the next step in the sequence. What do you do to 2 to get 3? Well, it isn't multiply by 2, it's add 1 again. And so it is for the next step from 3 to 4. So we've cracked the code. Now we're sure about our rule, it's add 1, we can apply it to the last number, the 4, to get the missing number. 4 add 1 is 5. So the missing number is 5. Number sequences in the test are usually a bit more tricky than this, and the rule you're looking for may be a bit more complicated. So let's get back to your question.
OK, I've got to find some rule that applies to each of these numbers to give me the next one in the sequence. Well, to get from 1 to 3, I can add 2. But if I look at the next step and add 2 to 3, I don't get 6. So adding 2 can't be the rule. But what else can it be?
Well, don't give up. What is the next step?
From 3 to 6 is either times 2 or add 3. So that doesn't give me a rule either.
Well, then try the next step. That might settle it.
OK, to get from 6 to 10, I add 4.
So what's the rule for this number sequence?
Oh, I see. It's add 2, then 3, then 4. The number I add increases by 1 each time.
You've cracked the code. Well, now you've worked out the rule, apply it to the last number.
If I have to increase what I add by 1 each time, then the next step will be add 5. 10 add 5 is 15, so the missing number is 15.
So write it in the box for 1 mark. Now, don't forget there's another part to this question. It asks you to explain how you worked it out.
Oh, so I write in that the amount I added on each time went up by 1.
There are often questions like this, where the answer is a word or a sentence instead of a number.
There's a special name for this sequence of numbers. They're called triangular numbers, and this is why. Each of these numbers can be made into a triangle shape. Start with 1, then 3, then 6, then 10, then 15. Here's another special sequence of numbers. They're called square numbers. This is why. Each of these numbers can be made into a square shape. Start with 1, then 4, then 9, then 16, then 25. And you get a square number when you multiply a number by itself. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, and so on.
Here's another question with the number sequence. It says, Megan makes a sequence of numbers starting with 100. She subtracts 45 each time. Write the next two numbers in the sequence. And they give 100, 55, 10 and 2 boxes. With this one, they tell us what rule to apply.
Yes, but there's something to watch out for here.
Right. 100 minus 45 is 55, and 55 minus 45 is 10. So 10 minus 45 is, oh, I've got to be careful here, we're going into negative numbers.
Well spotted. Let's hold it there and look at an easier number sequence with some negative numbers, like this. The rule is that we're subtracting 2 each time, which is fairly simple until we get to the number 1. Then what happens when we subtract 2? Subtract 2 from 1 is 0 minus 1. So the first missing number is minus 1. And if you subtract another 2, minus 2 minus 3. So minus 3 is the next missing number. Does that help?
Okay, so 10 minus 45 is minus 35, and minus another 45 is minus 80.
Another 2 marks. When we talk about numbers, there are some special words worth remembering. An even number is divisible by 2. An odd number isn't. A prime number is a number that is only divisible by itself and 1. Let's spot a few prime numbers. Now 1 doesn't count as a prime number, so what's next? 2. Can it be divided by another number? No, so it's a prime number. 3. No, so it's a prime number. 4. Well, 4 divides by 2, so it's not a prime number. 5. A prime number. 6. Divides by 2 and 3, not a prime number. 7. A prime number. 8 divides by 2 and 4, not a prime number. 9 divides by 3, so not a prime number. 10 divides by 2 and 5, not a prime number. 11, a prime number, and so on. To check if a number is a prime number, it's useful to know some shortcuts to whether a number is divisible and by what.
A number is divisible by 2 if the last digit is even. A number is divisible by 3 if the sum of all the digits is divisible by 3.
A number is divisible by 5 when the last digit is 0 or 5.
A number is divisible by 9 if the sum of all the digits is divisible by 9.
A number is divisible by 10 if it ends in a naught.
Once you've got your divisibility rules sorted out, you can tackle 2 other useful words: multiples and factors, and the difference between them. A multiple is what you get when you multiply numbers together. We say that 10 is a multiple of 5 because you can multiply 5 by 2 and get 10. We can also say that 10 is a multiple of 2 because you can multiply 2 by 5 to get 10. So 10 is a multiple of both 5 and 2. A factor is a number you can divide exactly into another number. 5 is a factor of 10 because you can divide 5 into 10. 2 is a factor of 10 because you can divide 2 into 10. 5 and 2 are both factors of 10. Let's try to break down 12 into its factors. What divides into 12? 1 and 12. 2 and 6. Anything else? 3 and 4.
Here's a question about multiples. It says, Millie and Ryan play a number game. What's my number? Is it under 20? Yes. Is it a multiple of 3? Yes. Is it a multiple of 5? Yes.
Well, have a go.
Multiples of 5 are 5, 10, 15, 20, but it has to be less than 20. That leaves 5, 10 and 15. But the number has to be a multiple of 3, and 3 only goes into 15, so the number must be 15.
So write it in the box. A formula is some maths where the numbers are replaced by letters. Look at this missing number question. It says 60 take away something equals 26. We could write that as 60 minus some number equals 26. It would be shorter to write 60 minus n instead of some number. Or we could write 60 minus y equals 26. The maths would be exactly the same. Can you work out what y is?
Well, if the difference between 60 and y is 26, then y is the difference between 26 and 60, which is 34.
Right. There's a reason for using a formula and having letters instead of numbers in your maths. It's when you don't know what the numbers are, but you do know the relationship between things. Look at this question.
There are 12 pencils in a box. A school buys 24 boxes. How many pencils does the school buy?
In our program on problem solving, we worked out that if there are 12 pencils in one box, then in 24 boxes, there are 24 times 12 pencils altogether. The total number of pencils is the number of pencils in one box multiplied by the number of boxes. Now that's true however many pencils there are in each box and however many boxes. So we can write a formula that will work for any number of pencils and boxes, and that is T for total pencils equals P for the number of pencils in each box times N, the number of boxes. And so we don't confuse the multiplication sign with an X, we write it as T equals Pn.
Here's a question that asks for a formula. It says, to print a book, it costs 3 pence per page and 75 pence for the cover. Write a formula for the total cost of printing a book with a cover. If T stands for the total cost in pence and N is the number of pages.
Off you go then.
Well, if each page costs 3 pence and there are N pages in the book, then the cost of the pages is 3 times N. Then I need to add the cost of the cover, that's 75 pence. So the total cost in pence, that's T, equals 3N plus 75.
In the box it goes. That's the end of our program on numbers and number sequences. So let's check what we've done. We looked first at number sequences and saw how you have to spot the mathematical rule that applies to each step of the sequence, and then how to use it to get the missing number. We looked at special numbers like odd and even, prime numbers and squares, as well as multiples and factors. Finally, we saw how you can create a formula by replacing numbers with letters. If you want to, you can go over all this by winding the tape back and looking at bits of the program again. And there are also books, an audio tape, and our interactive Revisewise website to help you prepare for your tests.
The next program is about interpreting data.
In these programs, and in our books, audio tapes and on the internet, we're helping you with the things you might find tricky in your Key Stage 2 maths tests. This time, it's how to interpret data. Now, what do we mean by that? Well, in the test, there are lots of questions that give you data or information in different ways, and you have to interpret it. That is, to work it out and explain what it's telling you. Here's a question where they give you a table of figures about the cost of stamps, and you have to work out how much it costs to send a letter. This one has a bar graph showing you the number of people who went into different shops. This is a graph of someone's temperature when they were ill in hospital. One thing they all have in common is that they each tell a story, and you have to work out what it is.
Here's a question with a table of figures. Can you help me with it?
Okay, what does it show?
Well, it's a table of the number of stamps used each day in school. Then it has the days of the week and the prices of the stamps.
Let's have a good look at that table and see what it's telling us. To start with, it's got a title, and that tells you what the table is about. That's the number of stamps used each day in the school. Then it shows you the two things that the table is comparing, the days of the week across the top and the price of the different stamps down the side. So, for example, this row across tells you how many 30p stamps were used on each day of the week. 6 on Monday, none on Tuesday, 2 on Wednesday, 8 on Thursday and 4 on Friday. This column downwards tells you how many stamps were used on Thursday. 32 19p stamps, 6 25p stamps, 8 30p stamps, 1 35p stamp and 12 50p stamps. So what does the question ask?
Well, it asks how many 25p stamps did the school use on Wednesday. So if I go down the column for Wednesday and across the row for 25p, then the answer is where the two meet. That's 4.
Well done. Write it in the box and get a mark. Tables are a popular way of showing information. You see them everywhere, and they all tell you different things.
Here's a table showing different mobile phone tariffs. Here's a football league table with the teams listed down one side. This is a bus timetable with the places it stops down the side and all the times going across. Even the TV listings are in a table with all the different channels across the top and the times down the side.
When you're preparing for your test, have a look at some tables like these to get the hang of how they work and the information they're giving you. Bar graphs are another way of showing information.
There's a bar graph in this question. It's about how much money some children collected.
Let's have a good look at that bar graph. Like a table, it has a title that tells you what the bar graph is showing you. That's the amount of money they have raised so far. Then it shows you the two things that the graph is comparing. The names of the children up the side, that's the vertical axis, and the amount of money in pounds that each of them has raised along the bottom. That's the horizontal axis. Another thing to watch out for is what each division along the horizontal axis is worth. That's the scale. In this case, 1 division equals £1. This bar, for example, tells you how much money Hassan raised. To find out the exact amount, you go from the end of the bar to the amount in pounds axis. And there you can read the figure 5, which means £5. So what does the question ask you?
It wants to know how much money the children raised altogether. So if I look at each bar in turn, I can see how much money each child raised and then add it all up. So Louise raised £3. son raised £5. David raised £4. Sarah raised £7. And Donna raised £6. So that's 1, 10, 10, 5. That's £25 altogether.
Now on that bar graph, each division along the horizontal axis was exactly £1, so it wasn't difficult to work out the value of each bar. It's not always that easy.
This is a bar chart. It shows you how many cars are sold over a period of 8 months. The month that sold the most cars was the 8th, and they sold just under 80 cars.
Notice how the length of the tallest bar didn't exactly line up with a numbered division on the axis, so Emma had to estimate that the amount was just under 80 cars. You often have to look carefully at the numbers on a bar graph, because very few have one division on the graph worth exactly 1 unit of measurement. In this bar graph, the numbers on the vertical axis go 0, 4, 8, 12. So each division is worth 4 people. To find out what the post office bar is worth, the line you take across ends up halfway between 20 and 24, which must be 22.
Here's another bar graph, and this one's got centimetres along the bottom that go 0, 25, 50 and so on. So each division here is worth 25 centimetres.
Can you answer the question that goes with it?
Well, it says, Sue jumped 212 centimetres. Draw Sue's long jump on the graph. So I'm looking for 212 centimetres along this axis. But it isn't there.
Then you have to work it out from the numbers that are there.
Oh, I see. 212 is about halfway between 200 and 225. So I'll make a mark there and draw the bar like this.
Bar graphs are a useful way of showing information, and when you're preparing for your test, look out for them and work out what they're telling you.
Here's a bar graph showing the money people in different countries spend on their gardens. This shows the sale of musical instruments and how much people spend on different kinds of music. You can even make bar graphs of your own on a computer from information you've collected in a spreadsheet or database.
Line graphs tell a story too. Over to the maths team.
This is a Weight Watcher graph. It shows that a person weighed 90 kilograms before they started the Weight Watchers course. During the course of 24 weeks, they lost weight, but in the last 4 weeks, they gained weight.
Graph questions in the test are often about working out the story behind the graph. Try that one.
Well, it's about Gavin, who is ill, and this is his temperature chart.
And what can you tell by looking at it?
Well, it starts on the 5th of March, when his temperature is low, and then his temperature gets higher until the 10th of March. And then it comes down again and levels off by the 15th and 16th of March.
Well, that sounds like the story behind the graph, but what does the question ask you about it?
It says, estimate Gavin's highest temperature, shown on the graph. Give your answer to 1 decimal place. OK, so the highest temperature will be where the graph is at its peak. That's here.
Yes, but what's his actual temperature?
Oh, I'll run along the line to the temperature axis and read off what it says. That's... oh, it's not by a number. It's in between 38 and 40.
But the question does say that you have to estimate.
So this division between 38 and 40 must be 39. And my line is just a bit higher than that, so I guess it's somewhere around 39.1 or 39.2.
Well, that looks just about right to me. This is a different kind of line graph. Along the horizontal axis are pounds, and at the vertical axis are dollars. Let's say that £10 are worth $15, so I can put a point on my graph here. I also know that no dollars equals no pounds, so I can put another point on my graph here. Now, if I join my 2 points together, I get a straight line which tells me the relationship between pounds and dollars. Now we've got the graph, we can use it to convert any number of dollars to pounds, or the other way round. Over to the maths team.
This is a conversion graph showing how to change pounds into dollars. To find out how many dollars are in £6, I will go across to the 6, get a ruler and go up to the line and mark out, and then I'll do the same again. Go across onto the other axis and it will be $9.
There's one more type of chart you might come across in your test, and that's a pie chart. You can guess why it's called that because it's circular like a pie, with the different amounts shown as different sized sections of the pie. The maths team explains.
This is a pie chart. It shows you how many hours of the day were spent on a particular task. I can see that about a quarter of the day was spent working and a quarter of the day was spent playing. About a third of the day was spent sleeping and about an eighth of the day altogether was spent on travelling and eating.
Look out for pie charts and investigate what they mean.
This one shows how much of these different fish dishes were eaten in this restaurant. These two pie charts show how people spend their money on their gardens. You can make pie charts of your own on a computer.
That's the end of our programme on interpreting data. So let's just check what we've done. We looked at tables of figures and how to read information from their rows and columns. We looked at bar graphs and saw that they have horizontal and vertical axes and a scale, and how to estimate the length of the bars. We saw how line graphs can tell a story and how to read them, and we used a straight line graph to convert from one thing to another. Finally, we saw that pie charts show information by the different sizes of their sections. If you want to, you can go over all this by winding the tape back and looking at bits of the programme again. And there are also books, an audio tape and our interactive Revisewise website to help you prepare for your tests. So, we'll let you get on with your test and you get on with your television revision.
The next programme is about data handling.
In this programme, we're helping you with things you might find tricky in your Key Stage 2 maths tests. This time, it's data handling.
What do you mean by that?
Well, data is information, and in maths we usually get information as lots of numbers. Now, here's a table of test scores for a group of 9 children. Now that list of numbers is difficult to make much sense of at a glance.
You could use them to plot a graph.
That's right. And this is the graph we'd get, which gives us a picture of the different marks people got. But there's more information we can get out of the numbers themselves. What if we wanted to compare these results with the following week's test, or with marks from another class? It would be really useful to have one number that gave an overall result of the whole class. Now this is where we need to use mode, median and mean average. There are 3 different ways of getting an overall figure for this class's test results, and each way will tell us something different. The mode is the number that comes up most in a set of numbers. It's easier to work out what it is if you put all the numbers in order first, from the lowest to the highest. So, what number comes up most often? Well, there are 2 6s and 2 9s, but there are 3 4s. So, 4 is the mode, the mark that most people got.
I can see how the mode can be useful to know, but what's the next way?
It's the median. The median is the middle value of a set of numbers. To find out what it is, first sort them in order, and then you can pick out the middle number. And there are 9 numbers altogether, so the middle value is the 5th one along, which is 6. So the median is 6, the middle test score that people got.
I can see that's a good measure of what the whole class scored.
Now, don't forget the third way, the mean average. Another way of getting an overall figure for the whole class is to add up everyone's marks and divide this total by the number of children in the class. The total of all the marks is 63, divided by 9, the number of children. That makes 7. So the mean average of this set of numbers is 7.
It's as if the children's marks have been shared out equally between them.
That's right.
I like that method. It seems the fairest way of measuring how the whole class got on in their tests.
But is it? Look at this.
On your marks.
Well, I think we have a replay of the race, Chris, and would you like to talk us through?
Well, I got a great start, and it didn't take me too long to get past Yusuf. And, you know, really, by the time I handed over the baton, we was over 50 metres up.
We're with Holly Brook now.
Natalie, I understand, ran her personal best, but even with a good handover to Marcus, they were over 50 metres behind.
Holly Brook are well behind. Gemma, Marlborough's third leg, has already passed the baton to their final runner, and Kate has an impossible task making up the lost distance, and she's catching up. 30 metres to go, and Kate is closing on the red team, whose last leg is being run by 5-year-old Shakira Akabusi, and it's going to be a photo finish. Quite remarkable. It's a dead heat. Let's have a look at the timings there with Brendan Foster.
Well, in the green, Yusuf started with 18 seconds. Natalie on the second leg ran 17 seconds. Then Marcus ran 100 metres in 16 seconds, with the last leg being run in 19 by Kate. 70 seconds to run 4 by 100 metres, an average of 17.5 seconds a leg.
Well, now let's take a look at the red team. Chris ran his leg in 11.5 seconds. Quite amazing timing. Followed by Barnaby, who ran in 15 seconds. Very good. Gemma ran the third leg in 17 seconds. In the final leg, Shakira, the up-and-coming 5-year-old from the Akabusi camp, took 26.5 seconds to finish the race. A total of 70 seconds for 4 by 100 metres.
Well, that's an average also of 17.5 seconds a leg, exactly the same as the green team.
The same mean average for 2 very different races.
Let's go back to our test results. Say one pupil scored nothing in the test. What would the mean average be then? Add up all the scores, 54, and divide by the number of children, 9. That makes 6. So the mean average for this class has gone down from 7 to 6.
Oh, that isn't fair, because all the other children in the class did just as well. What happened to the median and mode?
Let's see. Sort the numbers into order first. the middle value is still 6, so the median is the same as it was before. And the score most people got, the mode, is still 4.
So maybe the mode and the median are fairest after all. The mean average can be misleading if one person gets a very different mark from the rest of the class.
That's right. One person getting 0 pulled the mean average for the class down 1 whole mark, but it didn't change the median or the mode.
Here's a question about mean and mode. It says, write a different number in each of these boxes so that the mean of the 3 numbers is 9.
OK, give it a go.
Well, if the mean of the 3 numbers is 9, then the total of those 3 numbers is 3 times 9. That's 27.
Good.
Now, I want 3 different numbers that add up to 27.
That's right.
Well, if I can't have 9, 9 and 9, I could have 8, 9 and 10. They add up to 27.
Yes. Any 3 numbers that add up to 27 would be right, even something like 1, 2 and 24. Now, what about the next part?
This time they've got 5 boxes and want a number in each of the boxes so that the mode of the 5 numbers is 11.
So, what's the mode?
It's the number that appears most. So it doesn't matter what the other numbers are as long as I have more 11s than any other number.
That's right.
OK, so I'll write 11 and 11, 1, 2 and 3.
Yes, well done. Probability is about how likely or unlikely it is that something will happen. It's about using maths to work out the chance of something happening or not. We can describe probability on a scale from 0 to 1. Over to the maths team.
The probability of something that's definitely going to happen is a whole.
The probability of something that's definitely not going to happen is 0.
So at one end of the probability scale are events that are impossible. They'll never happen. They have a probability of 0. At the other end of the scale are events that are certain. They definitely will happen, and they have a probability of 1. Along the probability scale between impossible and certain, we put events that are unlikely but possible, equally likely to happen or not, or very likely to happen. A fair coin has 2 faces, heads and tails. And when I toss a coin, there's an equal chance of it coming down heads or tails. And over several goes, I'll get heads half the time and tails half the time too. Now we can say the probability of getting heads is 1/2, and the probability of getting tails is 1/2. We can work this out mathematically. How many heads are there on the coin? 1. Divide that by the number of ways the coin could fall, heads or tails, that's 2. So the probability of getting heads is 1 divided by 2, and that's 1/2. And we can show that on the probability scale. A fair dice has 6 faces with 1 to 6 spots on them. And when I throw a dice, what is the probability of me getting, say, a 4? OK, let's work it out. How many 4s are there on the dice? 1. How many numbers are there on the dice altogether? 6. So the probability of throwing a 4 is 1 divided by 6, and that's 1/6. So, what's the probability of throwing an even number?
Well, I have to work out how many even numbers there are on the dice. and then divide it by the total number of ways the dice can come up. The even numbers are 2, 4 and 6, so there are 3 even numbers and 6 ways altogether the dice can fall. So the probability of an even number coming up is 3 divided by 6. That's 1/2.
That's right. Spinners are many-sided shapes like this, with each section numbered. This one has 6 sections numbered 1 to 6. If you spin it like this, it'll come to rest on one of the numbers. What is the probability of a number, say 3, coming up?
Well, there's 1 3 on the spinner, and there are 6 numbers altogether, so it'll be 1/6.
What about this spinner then? It's got 8 sides numbered 1 to 8. What's the probability of a 3 coming up now?
Well, there is still only 1 3 on the spinner, but now there are 8 numbers. So the probability must be 1 divided by 8. That's 1/8.
That's right. If you get a question about a spinner, check how many sides it's got, what numbers it has on it, and how big each section is. That's the end of our programme on data handling. So, what did we do? We learned that data handling means getting information from a set of numbers. The mode is the number that comes up most. The median is the middle value of a set of numbers. The mean average is the total of all the numbers divided by how many numbers there are. We looked at probability. How likely or unlikely is it that something will happen? We saw that the probability scale goes from 0 for events that are impossible to 1 for events that are certain. We saw how the probability of other events happening can be worked out as a fraction. If you want to, you can go over all this by winding the tape back and looking at bits of the programme again. And there are also books, an audio tape, and our interactive Revisewise website to help you prepare for your tests. So, we'll let you get on with your test, and you get on with your television revision.
The next programme is about measures.
In this programme, to help you with your Key Stage 2 maths tests, we're looking at measures.
What do you mean by that?
Well, we use different units of measurement to measure different things. Like this.
When you go shopping, you'll find that packets of solid things are marked in grams. Larger packs are marked in kilograms. Liquids are marked in litres. And some things are marked with their length or width in metres or millimetres.
And all those quantities are measured in different ways.
We measure small distances with a ruler. We measure longer distances with a tape measure. We measure even longer distances with a trundle wheel. Liquid capacity is measured in a measuring jug. And weight is measured on scales.
All those ways of measuring have both large units and small units. In mass and weight, it's kilograms and grams. And it's important to know the relationship between them.
1 kilogram is the same as 1,000 grams.
1 kilogram, 1 gram.
To convert from one to the other, you multiply or divide by 1,000. So if 1 kilogram equals 1,000 grams, 5 kilograms equals 5,000 grams. You multiply by 1,000. 500 grams equals 0.5 kilograms. You divide by 1,000. With capacity, it's litres and millilitres.
1 litre is equivalent to 1,000 millilitres.
1 litre, 1,000 millilitres, 1 millilitre.
With distances, it's kilometres and metres.
1 kilometre is equivalent to 1,000 metres.
1 kilometre equals 1,000 metres. 4.5 kilometres equals 4,500 metres. Multiply by 1,000. 500 metres equals 0.5 kilometres. Divide by 1,000. For smaller distances and lengths, we use metres and millimetres. 1 metre equals 1,000 millimetres. There's another unit of length measurement you'll come across, the centimetre. And 1 metre equals 100 centimetres. 1 centimetre equals 10 millimetres. So to convert between these, you either multiply or divide by 10 or 100. There are often test questions about using different units of measurement to see if you know the relationship between them. Try that one.
Well, there's a picture of a model car and it says, the height of the model is 2.8 centimetres. The height of the real car is 50 times the height of the model. What is the height of the real car? That's easy. The real car will be 50 times 2.8, which is 140 centimetres.
But check exactly what the question is asking you.
Oh, it says give the answer in metres, so I have to change 140 centimetres into metres.
That's right.
Well, I know there are 100 centimetres in 1 metre, so 140 centimetres is 1.4 metres.
So write it in the box for 2 marks. So with problems involving measurement of distance, mass and capacity, watch out you give the answer in the correct units and know how to convert between them. Now look at the first part of that same question.
Well, there's a picture of the model car with a ruler underneath it, and it says, what is the length of the model? So what am I supposed to do?
Well, they want you to measure it. There are often questions like this to see if you can measure things accurately. So that's something worth practicing, like using a ruler. The maths team show us how to do it.
I got a ruler and turned it over to the millimetre side. Then I placed it up against the line exactly and measured along. It was 120, then I counted the millimetres on from it to the end of the line. And there were 7 of them, so altogether it was 127 millimetres long.
So the trick when reading a scale, like on a ruler, is to work out what the small divisions are that come between the numbered ones.
Well, if this is like a ruler, then I suppose the small divisions will be millimetres. So it's 8 centimetres and 5, 6, 7 millimetres.
Yeah, but check the question.
Ah, it says it wants the answer in centimetres to 1 decimal place. So 8 centimetres and 7 millimetres will be 8.7 centimetres.
Good. In the box. The other kind of measuring you may be asked to do in the test is to measure angles using an angle measurer. Over to the maths team.
I put the cross onto the point and make sure that the red arrow is level with the line. Then I move it down to the next line and it measures 60 degrees.
You try one.
OK, there's a little drawing of an arrowhead and it says, below is part of a larger scale drawing of the arrowhead. The drawing has the same size angles as the design. Draw 2 more lines to complete the arrowhead accurately. Use an angle measurer, protractor. So they want me to make an angle of 40 degrees here and here. And it's telling me to use my angle measurer. So here we go. I put the centre hole of the angle measurer over the end of the line, line up 0, then I turn the red line to 40 degrees and make a mark. Then I do the same on the other side.
And that's great for the angles, but don't forget they want you to complete the arrowhead.
So I need to draw 2 lines, like this. That looks okay.
Well done.
Here's a question about area and perimeter. Here, they want me to draw a shape which has an area of 10 square centimetres. And here, they want me to draw a rectangle which has a perimeter of 10 centimetres. Can you remind me of the difference?
OK. The test often has questions about area and perimeter, so it's well worth getting it clear what they are. The perimeter is the distance all the way round the outside edge of a shape. The perimeter of this rectangle is the length of this side plus the length of this side, and this side. Area is the amount of surface a flat shape covers. The area of this rectangle is the length of this side multiplied by the length of this side. Now, does that help you with the question?
Well, in the first part, they want me to draw a shape with an area of 10 square centimetres. It doesn't say it has to be a rectangle. Now, each square in the grid is 1 centimetre square, so I need to count any 10 squares, like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
How about the next part of the question?
Right, they want a rectangle which has a perimeter of 10 centimetres. That's the distance around the outside of all 4 sides. The length of 2 sides will be half that, which is 5 centimetres. So to get the length of each side, I want 2 numbers that add up to 5.
That's exactly right. So what will they be?
Well, 3 and 2 add up to 5, so I can draw 2 sides here. One 3 centimetres and the other 2 centimetres. And another 2 sides of 3 centimetres and 2 centimetres here to make my rectangle.
You got it. Some questions about area are not so straightforward.
Here's another area question. It says, this plan of a garden is made up of rectangles and triangles. The area of each rectangle is 12 square metres. What is the area of the whole garden?
That's a good one. A shape like that, made from other shapes put together, is called a compound shape. To work out its area, you need to break it down into the simpler shapes that go to make it up. The maths team deal with a problem like that.
To find the area of this shape, I would split it up into 2 rectangles down there. Then I would find the area of one rectangle. There's 3 down that side, and there's 1, 2, 3, 5 that way. Then I'd tie them together, and that would make 15. Now I'd work on the second rectangle, and there's 3 that way, and then 5 down there as well. And then times them together, and that would make 15 as well. And then add the answers together. That would make 30 centimetres squared.
Does that help?
Yes. In this question, the shape is made up of rectangles and triangles. So I have to work out the area of each bit.
That's right.
Now, it tells me that the area of each rectangle is 12 square metres, and there are 1, 2, 3, 4, 5 of them. So the area of all the rectangles is 5 times 12, that's 60 square metres. Now, I know these triangle shapes are half the area of the rectangles. So that's 6 square metres, and there are 1, 2, 3, 4 of them. So that's 24 square metres of triangles. If I add the area of the rectangles and the area of the triangles, I'll get the area of the whole shape. That's 60 plus 24, 84 square metres altogether.
Good. So write the answer in the box. That's the end of our programme on measures. So, what did we do? We saw how different things have different units of measurement, and that there are different ways of measuring them. We looked at how to measure accurately using a straight scale, like a ruler, and how to measure angles with an angle measurer. We looked at area and perimeter, and how to work out the area of compound shapes. If you want to, you can go over all this by winding the tape back and looking at bits of the programme again. And there are also books, an audio tape, and our interactive Revisewise website to help you prepare for your tests. So, we'll let you get on with your test, and you get on with your television revision.
The next programme is about shapes.
In this programme, to help you with your key Stage 2 maths tests, we're looking at shapes.
What sort of shapes?
All sorts of shapes. Now, most of the questions on shapes in the test paper are about knowing what they're called and how to describe them properly. Now, here they want you to draw a pentagon. Here they want you to pick out an octagon and a hexagon. Here they want you to say which of these shapes is an equilateral triangle and why. So, let's start by looking at some shapes that are two-dimensional. Two-dimensional shapes are flat. You can draw them on a piece of paper. And here are some 2D shapes. They've all got straight sides. And where the sides join, you get an angle. Any closed shape with straight sides that meet at an angle is called a polygon, which means many corners.
Well, that's not very useful, giving all those shapes the same name.
Well, hang on. Each shape has its own name as well. And the name each of these shapes has depends on the number of sides and angles it has. Over to the maths team.
This shape is an octagon. It's an octagon because it has 8 sides.
This is a pentagon. It has got 5 sides. This shape is a quadrilateral because it has 4 sides.
You're more likely to come across the regular versions of two-dimensional shapes. Now that's when all their sides are equal and all their angles are equal too. Then they're called regular polygons. So a regular octagon has 8 equal sides and 8 equal angles. A regular heptagon has 7 equal sides and 7 equal angles. A regular hexagon has 6 equal sides and 6 equal angles. A regular pentagon has 5 equal sides and 5 equal angles. And a regular quadrilateral has 4 equal sides and 4 equal angles.
I recognise that. It's a square.
A square is another name for a regular quadrilateral, which has all its sides equal and all its angles equal.
And they're all right angles.
That's right. So you can call this shape a quadrilateral because it has 4 straight sides, a rectangle because its opposite sides are parallel and equal and it has 4 right angles, and it's a square because all its sides are equal and it has 4 right angles. Now many shapes have more than one name. Over to the maths team.
This shape is a quadrilateral because it has 4 sides. It is also a parallelogram because both pairs of opposite sides are parallel.
This is a quadrilateral. It is a quadrilateral because it has 4 sides. It is also a rhombus because all the sides are equal.
Knowing the proper names of two-dimensional shapes and exactly how to describe them will be really useful to you in your test. A triangle has 3 sides and 3 angles where they meet. And there are different kinds of triangles, and you need to know something about them.
This is a triangle. It is also a right angle triangle because it has 1 right angle.
This is a triangle because it has 3 sides. It is also an equilateral triangle because all the sides are equal and so are the angles.
An equilateral triangle has all 3 sides of equal length and all 3 angles equal too. An isosceles triangle has 2 equal sides and 2 of its angles are equal. A scalene triangle has none of its sides equal and all its angles are different. Now, in a right angle triangle, one angle is a right angle. That's 90 degrees.
Here's a question about triangles. It says, here are 6 triangles. One of them is an equilateral triangle. Put a tick in the equilateral triangle.
Off you go then.
Well, an equilateral triangle has all its sides equal, so it's not that one or that one, but it could be that one or that one.
So how can you be sure which one it is?
Oh, I could use my ruler to measure each side.
And don't forget to use the equipment you've been given, like your ruler or angle measurer.
Well, those 2 sides are the same, but that one isn't. So it's not an equilateral triangle. But I can try this one. Those 2 sides are the same, and so is that one. So it's an equilateral triangle.
Well done. What about the next part of the question?
Well, it says, write one property which makes equilateral triangles different from all other triangles. Well, all triangles have 3 sides, But an equilateral triangle is all equal.
Well, that doesn't sound very mathematical. What do you mean by all equal?
Well, all its sides are of the same length.
We'll write that down then. In questions about shapes, avoid vague answers like it's all equal or it comes to a point. You may know what you mean, but unless you say what you mean in a precise mathematical way, you may not get the marks. An angle is where two lines meet. It's the amount of turn between the two lines, and it's measured in degrees. Different sorts of angles have different names. The maths team explains.
Acute is an angle which is in between 0 and 90 degrees.
A right angle is exactly 90 degrees.
An obtuse angle is an angle between 90 degrees and 180 degrees.
The angles on a straight line always add up to 180 degrees.
A reflex angle is always bigger than 190 degrees. The angle around the point is 360 degrees. That is a circle.
Three-dimensional shapes are solid. You can hold them in your hand. And three-dimensional shapes have faces, and where two faces meet, it's called an edge. Now, two edges meet at a corner, but the proper word is a vertex. Here are some more 3D shapes. Any solid 3D shape with flat faces is called a polyhedron.
They've all got the same name again.
Yes, but they've all got their own names as well. And the name of each shape depends on the number of faces it has and their shape. Over to the maths team.
This is a cuboid because it has 6 flat faces and some of them are rectangles.
This is a triangular pyramid. It has 4 flat faces and they are all triangles. This is a square-based pyramid. It has 5 flat faces. It has 4 triangle faces. It also has a square face.
This is a triangular prism. It has 5 flat faces and on either end there are triangles.
Let's have another look at some 3D shapes and their names. A cube has 6 faces that are all equal squares. A cuboid has 6 faces that are all rectangles. The opposite pairs of rectangles are the same. A pyramid has a flat base and sides that meet at a vertex. Now, this is a triangular pyramid because its flat base is a triangle. Now, this is a square-based pyramid because its flat base is a square. A pyramid with a circular base is called a cone. This is a prism. It has 2 opposite faces that are the same and parallel to each other. And this is a triangular prism because its opposite faces are both equal triangles. Now, this is a hexagonal prism because its opposite faces are both hexagons. And this is a rectangular prism because its opposite faces are rectangles.
Can I just check something? What's the difference between a prism and a pyramid?
Now, that's a good question. A lot of people get those two mixed up. A pyramid has a base and it comes to a point. And if you slice across it, the new face gets bigger and bigger as you go towards the base. A prism is the same all the way along. If you slice through a prism anywhere along its length, the new face will be exactly the same as the original face. The net of a three-dimensional shape is what it looks like when it's opened out flat. Here's a cube. if we unfold all the faces, it looks like this. So this is the net of a cube. Here's a square-based pyramid. What do you think it's going to look like if we unfold all the faces? So, this is the net of a square-based pyramid.
Here's a question about nets. It says, this is an open-top box. Put a tick for each diagram if it is a net for the box. Put a cross if it is not. And there are 4 diagrams with the base of the box shaded in.
So what do you do?
Well, I have to work out which of these nets will fold up to make the open-top box.
That's right.
Right. In net A, those 2 squares there and those 2 squares there will fold up to be the long sides of the box. And then that square and that square will fold round to make the 2 ends. So it is net A for the open box. In net B, those 2 squares fold up and that one folds round to make half the side. Those 2 fold up to make the other side. And oh, those 2 fold over the top, so it isn't the net for the open box. In net C, the squares at each end fold up and round to make the 2 ends and the sides, so it makes the open box.
And what about net D?
In net D, those squares fold up to make the 2 sides. That one folds round to make one end, and that one folds up to make the other. So it makes the open box as well.
In the box for 2 marks. That's the end of our programme on shapes. So what did we learn? We looked at some 2-dimensional shapes and saw how they all have special names and properties. We looked at some 3-dimensional shapes and saw how to describe them and what to call them. We learned that a net is the flat shape you get when you unfold a solid shape. If you want to, you can go over all this by winding the tape back and looking at bits of the programme again. And there are also books, an audio tape and our interactive Revisewise website to help you prepare for your tests. So, we'll let you get on with your test and you get on with your television revision.
The next programme is about space.
In this programme, to help you with your Key Stage 2 maths tests, we're looking at translations, rotations and reflections.
What are they?
Well, they're all different ways that shapes can be moved or changed.
What kind of changes?
OK. Take this T shape. It can move sideways or up and down. That's called a translation. It can turn round. That's called a rotation. And it can be reflected in a mirror. That's called a reflection. Rotation is when a shape is turned round. When you turn a shape around a point at its centre and it fits back into place, it's called rotational symmetry. The number of times you can do this is called the order of rotational symmetry. If we rotate this rectangle half a turn, It fits exactly into its original outline. Complete the full turn, and it fits again. And because there are two positions where this rectangle looks exactly the same, we say its order of rotational symmetry is 2. What is the order of rotational symmetry of this square? If we rotate it, how many times will it fit into its original outline? Let's see. After a quarter of a turn, it looks the same as it did at the start. After half a turn, it looks the same again. After 3/4 of a turn, it's the same. So, counting the original position, there are 4 positions where the square fits into the same outline. So, its order of rotational symmetry is 4.
There's a question on the test paper about that. It says, Kim has a shape sorter toy. How many different ways does each piece fit into its hole? So I've got to imagine I'm turning each shape round to see how many times it looks the same. I guess this first one will look the same after 1/3 of a turn and look the same again after another third of a turn.
Don't forget to count the original position.
So that's 3 ways it can go into its slot. The next one will look the same after a quarter of a turn, half a turn, and 3/4 of a turn. So altogether, that's 4 ways it will fit into its slot.
Good.
The next one will look the same after... No, it won't be the same again until it gets back to its original position. So there's only 1 way it will fit into its slot.
Good. Every shape will have an order of symmetry of at least 1, because there's always one position where a shape will fit back into itself. Here's another question about rotation.
There's a shape on the grid and it says, turn it through 1 right angle around point A. Draw its new position.
And it gives you a hint that you may use tracing paper.
OK, so if I draw the shape on the tracing paper like this, then I've got to turn it through 1 right angle. That's a quarter turn around point A. So if I hold it down here and turn it through 1 right angle, then that's where I draw the shape in its new position.
That's right. And turning the shape through a right angle the other way would be right as well. It's for questions like these about moving shapes that you're given a piece of tracing paper at the start of the test. So don't forget to use it. A reflection is the image of something in a mirror, like this. Now here's me, and there's my reflection. Now the dotted line between us is called the mirror line. Things nearest to the mirror line on one side are also nearest to the mirror line on the other. Things furthest away from the mirror line on one side are furthest away from the mirror line on the other side.
Here's a question about that in the test. There's a shape on a grid and it says, draw the reflection of the shape in the mirror line.
You can do that.
OK, that line is 1 square from the mirror line, so the reflection will be 1 square from the mirror line on the other side. That line goes away from the mirror line by 2 squares, so the reflection will go away from the mirror line by 2 squares on the other side. That will go there and that will go there.
Now, how do you check if it's right?
I can use my mirror.
That's right. Again, don't forget to use the equipment that you've been given.
If I put the mirror along the mirror line, I can check if the shape I see in the mirror is the same as the shape I've drawn. And it is. I know what symmetry is. It's when something's the same on one side as it is on the other.
Well, that's nearly right, but I think we need to be a bit more precise. Take a shape like this and draw a line through it. If the half of the shape that's on one side of the line is a mirror image of the half of the shape that's on the other side of the line, then the shape is symmetrical, and the line is called a line of symmetry. Here's another way of seeing if a shape has a line of symmetry. If you can fold the shape so that the two halves exactly fit over each other, then it's symmetrical. And the fold is the line of symmetry. Which of these triangles has a line of symmetry? Can you fold them exactly in two? Let's try the first one. Whichever way you try to fold it, it won't match up, so it has no lines of symmetry. If you fold this isosceles triangle like this, it will match up, so it has one line of symmetry. If you fold this equilateral triangle like this, it will match up, and like this, and like this. So it has three lines of symmetry. There are often questions in the test about symmetry, so it's worth looking at some other shapes and working out if they have lines of symmetry, and if so, how many. See if you can spot the shapes that have lines of symmetry before Mathman does.
Mathman, 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 Mathman. Oh, man. Uh-oh. There's the line of symmetry. Mathman, 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 Mathman. Yep.
Goodbye, little Caesar.
Ha ha! Mathman, 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 Mathman. Symmetry, symmetry. Mathman, 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 Mathman.
All right.
No line of symmetry.
Oh.
Here I go. Mathman, 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 Mathman. Symmetry. Mathman, Mathman, Mathman.
Oh, there.
Yeah, two lines of symmetry.
Here's a question about lines of symmetry. It says, here is a shaded shape on a grid made up of squares. Draw the line of symmetry of the shaded shape.
So what are you looking for?
I'm looking for a line that goes through the shape so that the two halves on either side are the same.
And don't forget, a line of symmetry doesn't have to be vertical or horizontal.
Ah, here we go. It goes like this.
So draw it on the paper. You could check it with your mirror. If you put it along the line of symmetry, the reflection of one half in the mirror should be the same as the other half on the paper. Coordinates tell you the position of a point or an object on a grid. Now here's a grid of squares. There's an owl in one of the squares, and I can tell you exactly which square it is. The owl is in column D and row 4. The square where column D meets row 4, I can call square D4. What square is the owl in now? It's in the square where column B meets row 3. That's square B3.
This way of naming squares on a grid is often used in maps, like this street map. I know that the BBC studios are in square G2. So I find column G and row 2. And where they meet are the BBC studios.
We do the same thing in maths, except that we have numbers going across as well as going up. Going across, or horizontally, is called the x-axis, and going up, or vertically, is called the y-axis. And if we want to locate points instead of squares, the numbers go on the ends of the lines instead of between them. So, what can we call that point A? Look along the x-axis first. It's on line 1. Then look up the y-axis. It's on line 4. So we can label point A using those two numbers, 1 and 4. And we write it like this, 1, 4, with the two numbers in brackets and with a comma between them. Now it's really important to get the two numbers in the right order. The x-axis number, the distance along, always comes first. The y-axis number, the distance up, always comes second. Now if we put the numbers the other way round, 4, 1, we get a completely different point. 4 along and 1 up, which is here.
Here's a question about coordinates. It says, A, B and C are 3 corners of a square. What are the coordinates of the other corner? So I need to draw the square first, like this. So the other corner of the square is there. That's 4 along and 3 up.
So, what would you write down?
4 and 3 with a comma in between.
Good. That's the end of our programme about moving and changing shapes. So, what did we learn? We looked at translation. That's when you move a shape in a straight line. We looked at rotation, when you turn a shape round. And reflection, what a shape looks like in a mirror. We looked at symmetry, how some shapes can be folded exactly in half. And we saw how coordinates are pairs of letters or numbers that tell you exactly where a point or an object is on a grid. If you want to, you can go over all this by winding the tape back and looking at bits of the programme again. And there are also books, an audio tape, and our interactive Revisewise website to help you prepare for your tests.
The next programme is about mental maths.
In this programme, we're helping you with some of the things you might find tricky in your Key Stage 2 maths tests. Now this time it's mental maths.
That's doing maths in your head, isn't it?
That's right. Often it's quicker to do some maths in your head than it is to write it down or use a calculator. But in the mental maths test, you don't have a choice.
What mental maths test?
Well, there are 2 written papers and then there's a short mental maths test.
How do they test that?
Like this.
Here is the practice question to show you what to do. What is 6?
In the mental maths test, the questions are played from a tape.
What is 6 less than 25?
You work out the answers in your head and write them down on the paper.
Question 1. How many 20p pieces are there in £2?
That's completely different from the written tests. You've really got to concentrate with that tape going all the time.
That's right. And that's what we're going to help you with, to make sure that you make the most of what you know when you do your mental maths test. So, let's have a go. Before we start, you can't have any equipment to help you, so we'll get rid of the calculator, the angle measurer, the mirror, the tracing paper, and the ruler.
So I'm just left with my pencil?
Well, that's all you need. Oh, and your head to do the maths in.
But what am I going to write on?
This. It's the mental maths answer sheet, which has boxes on it for you to write the answers in. So, we're ready to start.
Key Stage 2 Mental Arithmetic Levels 3 to 5 test. You will have 5 seconds to work...
And remember, no talking during the mental maths test.
Question 1. How many 20p pieces are there in £2?
That's not too bad. £2 is 200p. So 20p goes into that 10 times.
Question 2.
Hang on a minute. I've only just done the first question.
That's right.
20.
For the first few questions, you have 5 seconds to answer each one. After that, there are some questions that give you 10 seconds to answer them, and then a few at the end that give you 15 seconds to answer them. Remember, once the tape has started, your teacher can't stop it, so it's important to keep up. If you get a question you can't answer in the time, forget it. Listen to the next question. Otherwise, you might miss a question that you can answer. It's also a good idea, if you can't answer a question, to put a big cross in the box. That'll stop you putting the answer to the next question in the wrong box.
How many millilitres are there in 2.5 litres?
OK, 2.5 litres is 2,500 millilitres. That's 2,500 millilitres.
How would 4:15 in the afternoon...
Hey, can we stop a minute? What's that 2.5 litres there for?
It was in the question. Sometimes important numbers from the question are printed on the answer sheet to help you, so you don't have to rely on remembering everything from the tape.
And the questions are all mixed up. We've had one about money and one about capacity.
That's right, they are mixed up. But they'll all be questions about the maths that you've done at school.
Put a ring around the fraction on your sheet.
That's a question about fractions.
A bus is due to arrive at 9:50. It is 25 minutes late.
That one's about clock times.
Subtract 40 from 120.
And that one's about subtraction. We can't go over all the different questions you could get in your mental maths test, but we can go through some of the things you can practice. When you're faced with a mental maths problem, first, work out what maths you need to do. Is it addition, subtraction, multiplication, or division? Look out for these words. First, for addition.
Addition means how many altogether.
It also means increase.
It also means plus.
It also means total.
It also means sum. It also means more than.
These are the words for subtraction.
Subtract means take away.
It also means decrease. It also means difference between.
It also means minus.
It also means less than.
It also means count back.
Multiplication words.
Multiply is the same as times.
It also means product.
It also means lots of.
It also means groups of.
It also means sets of.
And it also means repeated addition.
And division words.
Division means share equally.
It also means group equally. It also means divide by. It also means repeated subtraction.
If you know these words, you'll have no trouble spotting what the maths is you need to do. But how do you actually do it? To start with, know your number facts. Number facts are things you either know or can remember, so you don't have to work them out each time. One set of number facts that's always useful is our times tables. Over to the maths team.
1 times 4 is 4, 2 times 4 is 8, 3 times 5 is 15, 4 times 5 is 20,
6 times 6 is 36. 7 times 8 is 56.
9 times 9 is 81, and 10 times 9 is 90.
Once you're sure about your tables, you can use them to help with any multiplication problem. Have a look at this one. What's 40 times 70? Well, we know from our times tables that 4 times 7 is 28. 4 times 70 is going to be 10 times bigger. So that's 280. 40 times 70 is going to be another 10 times bigger. That's 2,800. The trick is to multiply the significant digits and then make sure you get the place value right by having the same number of zeros in your answer. Don't forget, addition facts are useful too, like all the pairs of numbers that add up to 10, or all the pairs of numbers that add up to 11, and all the pairs of numbers that add up to 12, and so on. Knowing these will help you do addition and subtraction really quickly. But what about division? Over to the maths team again.
A number is divisible by 2 if the last digit is even. A number is divisible by 3 if the sum of all the digits is divisible by 3.
A number is divisible by 5 when the last digit is 0 or 5.
A number is divisible by 9 if the sum of all the digits is divisible by 9.
A number is divisible by 10 if it ends in a naught.
Let's look at 59 plus 43. See how the maths team changed this sum into something easier on the way to getting the right answer.
To find the answer to 59 at 43, I'd turn the 59 into a 60, then at the end take away 1 and the answer would be 102.
With any number ending in 9, you can add 1 to make the sum easier. With a number ending in 8, add 2 to make the sum easier. And with a number ending in 7, add 3 to make the sum easier.
To find the answer to 43 at 59, I'd add 40 at 50, then 3 at 9, and then add the totals together, which will make 102.
What about subtraction? Try 54 minus 37.
To work out the answer for 54, subtract 37. I rounded the 37 to 40 and took it away, which was 14. Then I added on the 3, which gave the answer 17.
What about multiplication? Try 58 times 6.
This is how I would work out 58 times 6. I'd do 50 times 6 is 300, then 8 times 6 is 48, and add it together, which would equal 348.
Another tip when you're faced with a problem is to build on what you know. What's 30% of £5?
To find 30% of £5, I would divide by 10. To find 10%, and then times it by 3, which would make 30%. Altogether, it'd become £1.50.
Remember that percentages, fractions and decimals are all related.
50% is also equivalent to a half.
25% is equivalent to 1/4.
75% is equivalent to 3/4. 10% is equivalent to 1/10.
20% is equivalent to 2/10.
And to change a percentage into a decimal, divide by 100. So 50% is the same as 0.5. 25% is the same as 0.25. 75% is the same as 0.75. 10% is the same as 0.1. And 20% is the same as 0.2. Try this.
Put a ring around the fraction on your sheet, which is equivalent to 40%.
I know that 10% is 1/10, so 40% is 4/10.
Not all the questions on the mental maths paper are about numbers. Try this one. You've got 10 seconds.
Imagine a triangular prism. How many faces does it have?
Well, there are 2 triangular faces at each end and 1, 2, 3 sides, so that's 5 altogether.
That's the end of our programme on mental maths. So, what did we do? We saw how in the mental maths test you answer questions played to you on a tape. Questions that cover all the different kinds of maths you've done at school. We explained how it helps you to know the different words that describe addition, subtraction, multiplication and division, and how using number facts, like your times tables, will make it quicker to work out the answers. We saw how breaking problems down and building on what you know makes them easier to do. If you want to, you can go over all this by winding the tape back and looking at bits of the programme again.
And there are also books, a mental maths audio tape and our interactive Revisewise website to help you prepare for your tests.
So, we'll let you get on with your test and you get on with your television revision.